All right, welcome to Math 60. This is the video lecture for section 1.8. It is about modeling, but really what it's about is taking our different representations of mathematical ideas, which was this pictures maybe, or visual, or graphs, and numbers. It's really about being able to go between questions that come to us in the form of words and sentences and converting them usually into symbols, sometimes into pictures or numbers, but converting them so that we can do some math that tends to go a little bit faster when we use symbols than when we use words. So for example, suppose we have the following situation. And they have much richer examples in your textbook, but it's a lot of writing. I don't want to do that much writing by hand, so I'm going to make real short little examples. You have 20 apples let's see, every other day you eat 3 apples. Model the number of apples you have left on any given day. All right, so that's a mathematical situation, and it's in a very verbal form, lots of words. I read this as a sentence. If I wanted to know how many apples I have on the 10th day, doing it just with the words might take me a while. So being able to convert it into another representation can help me go faster. Pictures would be great. But going directly from words to pictures can be challenging. So often, if we want to end up with a picture, we go through symbols and then come around to the graph or the picture later. So you need to be able to, in order to convert something that's in words to symbols, you need to be able to identify the mathematical relationships and the quantities in the verbal description. The best way to do this is practice. I can only do a couple short examples or else the video would be super long. And also everybody processes and thinks through these things a little bit differently. So work through the practice examples in the textbook, work through some of the extra exercises in the textbook, and do your worksheets and come to class with questions, because I will best be able to help you when I know the way that you like to think about these. But for me, I would start with what relationships do I care about? Well, one relationship is the starting number of apples. And the quantity that relates to that is 20 apples. And I also want to know about the rate of change of apples. And that is, let's see, every other day I eat 3 apples. So that's 3 apples every 2 days. I might also want to know, when do I run out of apples? But you see, that's not in this sentence. I'm going to have to do some math to get to that. So at this point, I could say, okay, the number of apples on day X should be, well, if X is 0, I'm going to start with 20. And every 2 days, I'm going to eat 3 apples. So let's see, how would that work? when X goes up by 2, I'm going to lose 3 apples. All right, so let me check that because honestly, I might not be sure that that's correct. So what I've done is I've come up with a possible formula, but I'm not sure it's right. So what I would recommend you do is try a different representation. Let's use a table or the numbers representation. Here's my day, that's X, and here's my apples. And I'm not going to worry about the formula yet. I'm just going to think through it. So on day 0, I have 20. Every 2 days, I eat 3 apples. So that means on day 2, I should have 17 apples left. And then on day 4, I'm going to eat, right? So that's taking away 3. On day 4, I'm going to eat 3 more apples. So I'm down to 14. And on day 6, I'm going to take 3 more apples. So I'm down to 11. So I can tell you that I feel pretty confident, not only with the table, but also that the table makes sense to all of you, even if this formula didn't. So the table can be a great way to get a sense for what we're trying to do here. Notice I'm increasing my X by 2 each time, and I'm decreasing my output, we could call that Y, and decreasing my output by 3 each time. And now let me check it against the formula I came up with. 20 minus 3 halves times X. So on day 0, X is 0, and I have 20 minus 0, which is 20. Okay, that works. On day 2, X is 2, so I put a 2 in for X. 3 divided by 2 times 2, where there's the multiplicative identity. So those cancel, and I'm left with 20 minus 3, which is 17. That's a good sign. Seems to be working. Let's try it on day 4. Oops. You can grab your calculator if you're not certain about that number, but that's 3 times 4, which is 12. And 12 divided by 2 is 6. So that's 14. Okay, yeah, no, I'm pretty much convinced. Using the table helped me either build a formula or at least confirm the formula that I think I came up with. And I strongly recommend you do this when you build a formula based on a verbal representation. Also go ahead and make a table based on that, and then check your formula against your table. All right, I decided there's actually one other thing I want to say about this is a model is a mathematical relationship, but all models break. There are X values or input values that don't make sense in the model. So let me try 100 days. Well, yeah, 100 days later. My formula would say 20 minus 3 halves times 100, which is 20 minus 150, which is negative 130 apples. And that doesn't make any sense. As soon as I eat my last apple, I'm going to stop eating apples. So this model does not work for all possible X values. It only works for a limited number of X values, and at a certain point, the model doesn't work anymore. Another way to think about this, and it's the second part of 1.8, is modeling inequalities. So let's think about this. Let's think about this same question. I have 20 apples. I will continue eating 3 apples every day until I have eaten all the apples. Which means, this means I will stop this process when the number of apples equals 0 apples. So my model, 20 minus 3 halves x, only applies when 20 minus 3 halves x is greater than or equal to 0. 20 minus 3 halves x is the number of apples I have, and it's only going to work as long as I have more than 0 apples. So modeling inequalities is pretty similar to just modeling any old mathematical situation, except now we like to think about maybe when does that model break down? What's some critical point? So for example, I want to buy Bad Bunny tickets. The ticket costs $400, and I can realistically save $50 per week. We're going to model my savings as an inequality. So we think about the mathematical relationships and the quantities. So we're going to think about the starting value. Well, I didn't say it explicitly because it takes a long time to write. I'm going to say I start with $0. And the rate of change, which is $50 each week. And then the maximum, which is going to be $400. So the way I would say is my savings should be $0 plus $50 every week. And I'll use X for my weeks. And I can simplify this a little bit. First of all, I'm going to drop the 0 since it's the additive identity. It just goes away, and also going to get rid of the dollar signs for now. It's just 50x. And as soon as I hit that $400, I'm going to stop my savings because I've made enough money to buy the tickets. So my model would become 50x is less than or equal to 400. And now I've written it as an inequality. Now I could ask things like, how much money do I have in week 3? So that would be 50 times 3, or $150. And how long until I can buy the tickets? That would say I want to find out the number of weeks until I get to $400. And I'll divide both sides by 50 to isolate the number of weeks, and I get x equals, I believe it's 8 weeks. All right, that's it for this video. There's a list of English phrases that convert to, actually I can show you. There's a list of English phrases that convert to math expressions. And so let me show you that list. It's in your textbook. Not a lot of people ever talk like this. I'm probably not going to say 2/3 of a number. I certainly wouldn't usually say the product of 2 and a number. I'm just going to say 2 times a number, right? But there are a lot of different ways to write it. And so here are some of the different ways you might see, at least in this class, maybe in some other classes, although probably you won't see it very often when you're actually modeling with mathematics. All right, that ends this video. Thanks for watching.